Hi, my name is Maggie Mulligan. I'm a sophomore Earth and Marine Science major and chemistry minor, and I would love the opportunity to be a learning assistant again. This semester, I just really enjoyed it, and I thought it was so special that I got to be a part of my peers' success, and I just loved coming to class every day and seeing the same students and seeing them working so hard at something and then watching them succeed was so rewarding. I also really enjoyed conveying the study strategies that worked for me, which is just practice problems, and I really loved being able to help other students realize what works for them and then having them come back to me and say that my advice helped them was just super special and rewarding. So I would love the opportunity to do that again. And some other fun facts about me: I have two younger sisters, they're both in high school, two dogs, and I am from Wilmington, North Carolina. The problem I'm going to go through today is a method of initial rates problem. So it says determine the rate law of the following reaction given the table of initial rates. And the reaction is A plus B plus C to products. And you can see we have 4 trials given. So what we'll start with is just writing out what we know so far. So we have rate equals rate constant times concentration of A to the X, B to the Y, and C to the Z. So we want to choose trials where all the concentrations are the same except for A. So that would be trials 1 and 3. So we do rate 1 and rate 3, and then we'll plug in those concentrations from the table. So it's 0.005 for A, 0.0025 for B, and 0.0010 for C. So that's for trial 1. So then we'll do trial 3. So A is 0.010, B is 0.0025, and C is 0.0010. And then we'll also plug in those rates as well. So it's 2.0 times 10 to the negative 4th, and also 2.0 times 10 to the negative 4th for trial 3 as well. So those concentrations are going to cancel, as well as the rate constant will cancel. So the rate constants divided by, or the rates divided by each other equals 1. So I'm just rewriting here what we have left. 0.005 to the x over 0.01 to the x equals 1. So that simplifies to 1/2 to the x equals 1. And anything to the 0 power is 1, so x equals 0. So that means our reaction order with respect to A is 0. And this means we can disregard A from the rate expression because anything to the 0 is 1, so it's not going to change the value. And we're just going to go ahead and repeat these steps for reactants B and reactant C. So the final thing to do is solve for K, so we can use any trial. I'm just going to use trial 1, and we plug in the values we found. So K times 0.005 to the 0 times 0.0025 squared times 0.001 to the first equals 2.0 times 10 to the negative 4th. So when you solve that out, you get K equals 32,000, and the next thing to consider is units. So each concentration is molar, and the rate is molar per second. So K has to be 1 over molar squared times seconds in order for the units to cancel out to get the correct unit. So when you plug everything in, that's what you get as your answer. Thank you. I really hope I get the opportunity to do this again next semester.